Hello everyone, this is the video lecture for Calculus 3, section 16.5, curl and divergence. Let me go ahead and give you two formulas. We got curl is grad cross f, that's kind of different, and divergence of f is equal to grad dot f. And when you have this grad symbol by itself, it's kind of an interesting thing here. What I'm trying to say is that it's an operator. That is an operator. So 165001. Let me show you how it works. I got f is equal to x y squared z squared, x squared y z squared, and then x squared y squared z. And they want the curl of f. So that's again grad cross f. Out of either of these, the cross product is definitely going to be the harder one because there's more operations going on. Obviously, a dot product is pretty easy, but let's go through this cross product stuff together. What it works like is del del x, del del y, and del del z. That's my grad, and then cross. Well, all this stuff. It's an operator. Essentially, I'm going to operate on whatever term it falls on, essentially. So as I go through, some of them will be operated on. Well, cross product always has a 0 to start with. And then x, so I'm going to see how I'm saying the derivative in terms of x, essentially. So the 2 is going to come down, 2xyz squared, that's a k position, plus derivative here in terms of x, yet again, 2x y squared z, that's going to be a negative j position, plus my y here, as you can see, the 2 is going to be in the front, 2xyz squared, that is a negative k position, always a 0 in the middle. My y over here, 2x squared yz, that's a positive I position. Guess we can kind of do that there. Z on this side, 2xy squared z, that's a positive j position, good enough. And z here, 2x squared yz, that's going to be a negative I position. And then finally a 0. Obviously, this is just a mess. So I have my i's here together. Notice that I have right here and right here 2x squared yz, 2x squared yz, one is negative, one is positive. It actually ends up being a 0. The next one, my j's, I got 2xy squared z, a negative 2xy squared z, again a 0. And then my k's, you can see I got a negative and positive yet again, 0. Your answer here is actually the 0 vector, but this is also an acceptable answer in WebAssign. It's kind of funny because at this point, when you get this curl of f equal to 0 vector, what it's saying is that your f is conservative. Which I think we had talked about in another lecture a while ago. All right, divergence of f is, remember, it's grad dot f. And so then I would have d dx, d dy, d dz, and then dot, and then, well, all this stuff. So x y squared z squared, x squared y z squared, x squared y squared z. Okay. Well, obviously I'm just linking these here together. So and it's going to be a scalar in the end. Remember that also. Derivative in terms of x, get x, or I get y squared z squared, plus in terms of y, the y goes away, x squared z squared, plus, and then finally z over here, I get x squared and y squared. Well, there you go. There's your divergence of f. Keep cruising. So now I got 165007. I got my f vector is equal to 6 e to the x sine of y, 2ey sine of z, and then 4ez sine of x. I think they wanted to make it confusing on us on purpose. You know, will this all end up being a 0 in the end? I don't think so, but, you know, you never know. So, just like last time, you can see that this will get very repetitive, and it's not really doing a lot of new stuff. I don't see any, like, truly new techniques here, personally. Okay, here we go. So the very first term is a 0, of course. And derivative here in terms of x is actually going to be a 0k, so that doesn't change anything. And then I got this in terms of x. Sine will go to cosine. 4ez cosine of x. That's going to be a negative j. Next line. This derivative in terms of y, the sine is going to go to a cosine. So 6ex cosine y. Again, that's going to be a negative k. Always a 0 in the middle. Derivative in terms of y here is actually going to be a 0. Here in terms of z is going to be a 0. Here in terms of z is going to be that sine goes to a cosine. 2ey cosine of z. That's a negative I position. And then finally 0. So, writing it out. And then I have here negative j. And then here in terms of the k. Again, everything's going to be a negative. Okay, there you go. Cool. Now for the divergence. Again, we got grad dot f this time. And so, writing it out, del x, del y, del z, then dot, well, all this stuff. 6ex sine y, 2ey sine z, 4ez sine x. Okay, these guys here together. So my derivative in terms of x actually does not change anything. My derivative in terms of y. Again, because it's in that e, it doesn't really change anything. And then my derivative in terms of z, yet again, because it's in the power there with the e, doesn't change anything. Okay, here we go. Okay, and it's maybe going to ask if it's conservative or not. I would say no, because my curl was not equal to 0. Okay, 16,5017. I have my f is equal to 5y squared z cubed 10x y z cubed 15x y squared z squared. Alright, curl f. So again, cross product. You can see how very repetitive this is. Just rewriting it all. Gets a little boring at times. Okay, phew, here we go. 0. In terms of x, I got my 10y z cubed, that's in the k position. In terms of x, 15y squared z squared, that's a negative j position. In terms of y, the 2 comes down, 10y z cubed, that's a negative k position. I'll also do that, plus 0. In terms of y, that's actually going to end up being a 30x y z squared. That's going to be a positive I position. In terms of z, the 3 comes to the front. We got a 15y squared z squared. That is a positive j position. In terms of z, that's a cube technically right there. Sorry for the bad handwriting. The 3 comes down, 30 x, y, z squared. That's a negative I position, and then a 0. And so my i's, you can see right here how they look very similar. I think they're identical, actually, yeah. So yeah, those are the same. We're good there. 0, essentially. My j's, you can see that they're the same as well. You're just going to cancel them. Obviously, there's a minus here and a plus there, 0. And the same thing there. They're the same, 0. Okay. So what we've just got is that this is conservative. Awesome. And so conservative, what now? Well, in this particular problem, it says, well, if it's conservative, now find your potential function, little f. And if you remember, that's grad little f is equal to capital F. And so what we do is we basically integrate both sides to get little f by himself, basically. So each one of these terms is going to be integrated unto its variable where it's placed. So, integral here in terms of x, gains in x plus c. Oops. Get an x, y, z cubed dy. Here my y is going to, actually, you know what? Yeah. My y is going to square, and then I divide it by 2. It actually makes the same thing. And then the last one, 15x y squared z squared dz. Again, integrating, I'm going to cube it. Divide by 3 would make literally the same thing again. And so you can see that your potential function is, well, basically this one piece, because there's no other pieces for it to be. And that's the end of that problem. 165011. Okay. So they want the same thing, that potential function, but only if it's conservative. So then I've got to go and find the curl and see if I can make it equal to 0. So the curl of f, I'm just going to kind of switch to the, I kind of assume that at this point you know what's going on. And so instead, let me just go through this right quick with you. So 0, always the first. This one in terms of x, the 2x z to the 5th. It's in k position. And then this one in terms of the x would be now a negative 10 x y z to the 4th, and that would be a j. Again, I put the minus in the front basically already. This one in terms of y, x z to the 5th, that's a k position, 0 in the middle. And then this one in terms of y, I get a 5x squared z to the 4th. That's going to be the I position. Finally, I have, in terms of z here, the 5 is going to come to the front. Hold on. For this guy right here, I was going to do it in terms of y. I think this has to be a negative because there's a negative k position. Okay. Anyways, so this is a positive j in the end. So 5xy z to the 4th. J, this would be a negative I, so this one in terms of z, so negative 5x squared z to the 4th I, and then a 0. Okay, so let's see what we got. In terms of I, you can see I got x squared z to the 4th, x squared z to the 4th, they cancel out. Okay, cool. In terms of my j's, I actually don't cancel them. They look pretty close, but I end up with a negative 5xy z to the 4. My z's actually don't cancel either. I'm left with this guy in the end. So not equal to the 0 vector, not conservative. And so then when they say, like, what's little f equal to? You're going to put a dne in there. Okay? You can't go and find it now. 165034. So I got a little r is equal to x, y, z. And they say that little r without a vector symbol is equal to the magnitude of r vector. They say that f my f vector here, sorry, let me redo that. My f vector is equal to r vector divided by, trying to make that a little bit better, r vector divided by little r to the p power. And they want to know what's the divergence of f equal to. So I was thinking of not doing this problem, but because it's confusing, I want to talk about it. That's r to the p. I mean, almost I would have you go and look at the problem to understand what they're asking for. So before we keep going, I need to actually write out what my f is supposed to really look like. So notice that I have my actual vector. So this is just going to be a vector, x over, and then I have this r, which is magnitude of this stuff, and then to the p power. So x squared, y squared, z squared, square root it, and then all that to the p power. And then you do the same thing for both y and z. That's what I'm going to do for the rest of the problem, is just my x's, assuming that you can also do the y and the z as we keep going. This is actually a pretty big problem, so here we go. My divergence then is going to be my del x, del y, del z, and then dot, and then all of this that we've already written, all to the p power down there, dot, dot, dot. And so notice that my dot product is going to be one big scalar, so my derivative in terms of x here is going to be quotient rule, essentially. So let me start work on this part. So I got low, here we go, low, I'm going to say p over 2, combining my powers, d high, so 1, minus high, and then d low, the p over 2 comes down to the front, x squared, y squared, z squared, all now to the p over 2 minus 1 power. Oh, and then I need to multiply it by the chain rule. That's a 2x. All divided by, and then my square of what's below. The square and square root should cancel, leaving just the p power. And then plus, and then you have to do it all over again for the y and the z. You can see how much of a mess this is going to be. So that's why I'm only focused on one, essentially. So here you can see that I have a lot of things going on. I think that these 2's are going to cancel one another. These x's combine to make an x squared with the p. And then this right here, this whole minus 1 stuff is kind of weird. But let me try to just simplify a tiny bit before we jump to the next step. P over 2. And so px squared. And I'm not really sure what I want to do with this guy in particular right there. Well, I'm sure because I have my notes. And then plus whatever. What I'm going to do is convert it back to little r's and stuff like that. And so what I have here is little r is with the square root, and he's now to the p power, minus x squared p times. And this is where it gets a little weird here. Because you can take this power and essentially do p over 2 and then minus 1 is p over 2 minus 2 over 2. And so then if you kept going, yeah, it's p minus 2 all over 2. Okay, so how does that work out? So I'm saying that I have r to the p minus 2 all over r squared. No, never mind. Hold on. Let's start over. Sorry. Again, this is going to be kind of weird. let me try to reorganize this right quick. I got p minus 2, and then divided by the 2 is going to be a 1/2 power. That's right. Now I'm remembering. This 1/2 in the bottom is required to make it into an r. Remember how I said that this right here was your r? And so I'm saying like all of this here to this power, this 1/2 power, is my r, thus leaving only this in my power. So it's kind of like saying r to the p minus 2. That's what it is. And this is r squared to the p power technically down there. Okay. Whew. I mean, basically, it's just that 2 down here is combining with all this stuff to make that square root. That right there, that 2 in the bottom, is a square root, and your r was including a square root. Okay, now we're good. R to the p minus x squared p, and then this technically here is r to the p over r squared. That's really what I wanted to do. R to the 2p there. If you want to push that into the denominator, notice that you're going to have the same common denominator for both of them. So I'm going to say r to the p plus 2 minus p x squared r to the p, and then all divided by now r to the 2p, and then because you pushed it down here, it's down here as well, plus 2 in the power. If this powers things is just making your head roll, you're not alone. Again, and this is, again, every time it's plus a lot of other stuff. Actually, you know what? At this point, I think we did finalize it. No, actually we didn't. We didn't. It's still, it's like this in all the places. Notice that I still have that x squared right there. Yeah, so we just keep going. So I think I could factor out an r to the p to the front, essentially. So r to the p power times, and then I got r squared minus px squared. And then in the bottom, because of the way it is, I'm factoring out a p. In powers of powers, not powers of powers multiply. It's the like bases add to their powers. So I'm saying that this is technically an r to the p, and then an r to the 2. Because I'm saying p plus 2. Well, then these guys are going to cancel. Oops. Again, there's still a lot going on. These other guys right there. Okay. Now what I'm going to do is combine all 3 of them together. Okay, so I want to look at every single one. They all should have this denominator. They'll all have these differences in the numerator. Okay, so all one common big denominator. Okay, here we go. R squared minus px squared, and then plus r squared minus py squared, plus r squared minus pz squared. Again, all this divided by r to the p, and then times r squared. So what do they have in common? Well, I can say there's 3r squared minus p times, and then I got x squared plus y squared plus z squared. And then r to the p, r squared. Well, this right here is an r squared as well. So I can factor out an r squared to the front, 3 minus p divided by r to the p, r squared, cancel those guys. And then finally, I'm just checking my math right quick, because it gets pretty interesting here. Yep, 3 minus p all over r to the p. That's their answer. And so do you have to go through all these steps? Probably not. On the second part, it says, basically, what is p equal to in order to find your divergence equal to 0? Well, what I'm doing is I'm setting this equal to 0 here. The bottom doesn't matter, but the top does, obviously. Again, anything divided by 0 is still 0. So it doesn't really matter what's in the denominator as long as the top is 0. So I'm basically saying 3 minus p is equal to 0. P should thus equal 3. There's your answer. Okay, done with that section. Thank you very much. Have a great day.